Good morning. Today we are going to discuss the second part of this chapter, dual nature of radiation and matter. In today's class, we will discuss about what is photoelectric emission, photoelectric effect, what is photoelectric effect, and next we will understand what do we mean by intensity and what is the meaning of frequency. Okay, let's start. What is photoelectric emission or photoelectric effect? In photoelectric effect, this is the experimental setup of photoelectric emission. In this setup, we can say this is my glass tube, and this part is my quartz window. In this window, light can fall on this plate. Okay, so this is my glass tube and this is my window, or it's called quartz window. This plate is called a photosensitive plate. On this plate, light is falling, right? And here we can say a voltmeter is connected and a milliammeter is connected, and here we have given a battery. Here the work of battery is not to provide current. It is not the source of current, but it helps the electron to move. Okay, it supports the flow of current. It is not the source. It acts like a supportive agent. So when this cathode, this plate, photosensitive plate is connected, look here, this photosensitive plate C is connected to the negative end of the battery. So as it is connected to the negative end of the battery, it becomes negatively charged. And here plate A is connected to the positive plate of the battery, so it becomes positively charged. The light fall on this plate C, photosensitive plate C. What happens? Electrons get emitted from this plate. Electrons get emitted from this plate. This is called your photoelectric emission. Due to the light, electrons are emitted. So this process is called your photoelectric emission. Light are emitted. Electrons are emitted from this plate C, and they try to move towards plate A. As they are emitted from this plate C, they have certain initial kinetic energy. Okay, when the light fall on the plate C and electrons are emitted, electrons have initial kinetic energy, but all the electrons have not sufficient kinetic energy to reach plate A. Look here, millions of electrons are emitting, and between these electrons there is repulsive force is also acting. So due to this repulsive force, though all the electrons have certain kinetic energy, but due to this repulsive force, all the electrons are not capable to reach plate A. All the electrons are not able to reach plate A. So here the role of batteries comes to work. Here the battery pushes these electrons to reach plate A. Those weak electrons which cannot reach this end are helped by this battery. Battery helps these weak electrons to reach this end. Okay, by the help of battery, all the electrons are now capable to reach plate A. As the electrons are moving from plate C to plate A, current is conducted in the circuit. Whole circuit current is flowing. So in this experimental setup, we observed that electrons are flowing, electrons are emitting because of light, and battery act as a supportive agent, not as a source but as a supportive agent in this experiment. This is your photoelectric emission, photoelectric effect. So in this experiment, we observe certain things. Before going to the experimental result, we will discuss certain points. First thing, that is, what is intensity? What do you mean by intensity? Look, intensity means suppose there is three bulbs. One is 20 watt bulb, one is 40 watt bulb, one is 60 watt bulb. We generally know that from this out of 3 bulbs, if we ask you which one will glow brighter, we'll obviously say that 60 watt bulb will glow brighter. That means it has more intensity. Which bulb will give you more light? 60 watt bulb. That means it has more intensity. So intensity means intensity gives us brightness. More brightness means more intensity. We can judge intensity by the factor called brightness. Object or light which has more brightness, I can say it has more intensity. So we can say that more intensity means more brighter. Second term, that is what is frequency. What is frequency actually? Look, we know visible light, there are 7 colors, Vibgyor, right? We studied in class 10th, that is red color has more wavelength and violet has less wavelength. As well as we also studied there is certain frequency term. What is that? That red color has less frequency and violet has more frequency. We have studied this in class 10th, right? That means frequency is related with the color of the light. Frequency is related with the color of the light. If we are changing the color, that means we are changing the frequency of light. If we are changing the power, we are changing the brightness, that means we are changing the intensity of the light. Okay, so hopefully we understood what is intensity and what is your frequency. Now let us jump to next thing, that how intensity will affect the current. In this experiment, if we change the intensity, how current will changes. In this experiment, we observed that when we increase the intensity, the current also increased. We are inserting here or throwing here more intensity light, more intense light. That means more light are falling on here, more and more light are falling on here. If more light is falling, it will emit more electrons. More electrons will emit from this metal plate. So we will get more current. Again I am repeating. Suppose I will increase the intensity. That means what will happen? More and more light will fall on this plate C. If more light fall on the plate C, what will happen? That this light will affect this metal plate and electron will emitted in more number. When I will apply more light, more number of electrons will emitted from this metal plate. So in the result, when there more electrons are emitted, that means in the circuit I will get more current. Okay, if I decrease the intensity, less number of electron will emit from this plate and I will get less current in the intensity. That means more intensity implies more current and less intensity implies less current. That means intensity is directly proportional to current. Intensity is directly proportional to current. So graph between intensity and current will be a straight line. Graph between intensity and current is a straight line. Okay. So if question asks you what is the show me that the graph between intensity and current, the graph will be a straight line. Next thing, we experimentally observed that suppose I have increased the intensity experimentally. What we observe in this experimental setup, that suppose I have taken low frequency light, light. Frequency of the light is very low. Now what I did, I have thrown more intensity. I have increased the intensity gradually. That means initially I have taken a light of 20 watt, then 40 watt, then 60 watt, then 80 watt, then 120 watt. Like this I have increased the intensity, but when the frequency was low and I have increased the intensity, I observed that there is no flow of current in the circuit. Current is not flowing in the circuit. When I changes the frequency, and that means suppose I have observed that at 100 Hz frequency मैं जितना भी चाहे आपका इंटेंसिटी इंक्रीज कर लूँ, करंट मुझे नहीं मिल रहा था. देयर इज नो करंट इन द सर्किट. देन I increase the frequency to 120 Hz and I observe there is no current now also. Then I again increase the frequency to 120 Hz and I observe there is no current in the circuit. Then I again increase the frequency 125 Hz. So for example, right, I observe there is no flow of current in the circuit. मैं चाहे जितना भी इंटेंसिटी इंक्रीज कर लूँ, इस फ्रीक्वेंसी में मुझे कोई करंट नहीं मिल रहा था. फिर मैंने क्या किया, थोड़ा सा और इंक्रीज कर लिया 126 हर्ट्ज को. मैंने देखा कि भाई अब तो करंट मिल गया. चाहे इंटेंसिटी जितना भी कम हो, चाहे इंटेंसिटी मेरा जितना भी कम हो, लेकिन इस फ्रीक्वेंसी रेंज में मुझे करंट मिल गया. इट मीन्स दैट स्टार्टिंग करंट, इनिशियल करंट इनिशिएट होने के लिए ये इंटेंसिटी के ऊपर डिपेंड नहीं करता, ये डिपेंड करता है फ्रीक्वेंसी के ऊपर. To initiate the current, to initiate the emission of electron, it depends certain range of frequency. At low frequency, electron cannot be emitted from this circuit. चाहे आप इंटेंसिटी कितना भी इंक्रीज कर लीजिए, लेकिन आपका करंट फ्लो नहीं होगा at low frequency. एक पर्टिकुलर फ्रीक्वेंसी के बाद ही आपका करंट फ्लो होगा. That means after 126 Hz current will flow in the circuit. फिर we have observed that at 30 Hz there is current, at 40 Hz 140 Hz there is current. Now if we increase the frequency, we can get current, but below 120 Hz चाहे आप इंटेंसिटी जितना भी इंक्रीज कर लीजिए, कोई करंट नहीं मिलता इधर. तो ये जो आपका 120 हर्ट्ज मुझे मिला, ये जो फ्रीक्वेंसी मुझे मिला, इस मिनिमम फ्रीक्वेंसी को हम बोलते हैं, एक पर्टिकुलर टर्म देते हैं, इसको बोलते हैं हम थ्रेशोल्ड फ्रीक्वेंसी. थ्रेशोल्ड फ्रीक्वेंसी. सो व्हाट इज थ्रेशोल्ड फ्रीक्वेंसी? Threshold frequency means it is the minimum frequency below which no emission of electron is possible. Okay, this is the minimum frequency at which electrons are emitted from the circuit. It is the minimum frequency. I can say this is the minimum frequency at which electrons start to emit from the plate C, from the photosensitive plate. Photosensitive plate. Okay, so this is called your threshold frequency. In this example, threshold frequency was 126 Hz. Okay, so this is my threshold frequency. Okay, now this is about your threshold frequency. Next. Okay, thank you for the today's class. In the next class, we will discuss about your graph between frequency and current and voltage and current. Thank you.